Temperature, done by Katherine Jepson, Lizzie Riley, and Erica Button.
There have been many different temperature scales and units developed over the years. Two of the most commonly used equivalent units of temperature are the degree Celsius and the Kelvin. Celsius, which was named after the Swedish astronomer Anders Celsius, is in the metric system. Celsius uses the boiling and freezing points of water as reference temperature values. It sets the freezing point at 0 degrees Celsius and the boiling point at 100 degrees Celsius. There are 100 equal intervals between the boiling and freezing point of water, and each of those are 1 degree Celsius.
This section is temperature scales. Temperature is the measure of either how hot or how cold an object is. The object's temperature determines in what direction the heat transfer works. And the heat transfer is when two objects touch, and the direction it goes is the heat it's transferred from the hotter object to the cooler one. Almost all substances expand in heat, except for a few, including water.
The Kelvin scale is also known as the absolute scale. The Kelvin scale was named for Lord Kelvin, a Scottish physicist and mathematician. The freezing point on the Kelvin scale is 273.15 K. The boiling point is 373.15 K. The 0 point on the Kelvin scale is called absolute zero and is equivalent to negative 273.15 degrees Celsius. The Celsius scale and the Kelvin scale are very comparable. A change of 1 degree Celsius is equivalent to 1 Kelvin on the Kelvin scale. Here is a helpful equation. Notice how both the Fahrenheit and Celsius abbreviations include a degree sign, but the Kelvin scale does not.
Density, done by Kate O'Reilly. Density is the ratio of the mass of an object to its volume. An equation for density is density equals mass over volume. When mass is measured in grams and volume in cubic centimeters, density is labeled in grams per centimeters cubed, which is the most common measurement. In this picture, the density of 4 substances is being compared: lithium, water, aluminum, and lead. Notice that each 10-gram sample has a different density. Remember, density depends only on the composition of a substance, not the size. Liquids also have different densities. As shown in this picture, corn syrup is more dense than water, and corn oil is less dense than water. Also, in most substances, when you add heat, it increases the volume, and because density is a ratio of mass divided by volume, it increases the density.